Hi and welcome to Tea Leaves Programming. Today we're doing Haskell for Dilettantes. We are finishing up the Applicative chapter of the FP course. I've complained a little on social media how Applicative is my least favorite type class because it's the one that makes me feel stupidest. So what is Applicative? Just to very briefly review, it is, and I'm stealing this term from the book Haskell from First Principles, a monoidal functor. So a lot of $10 words in there. I kind of hate it, but it is what it is. So a functor is something that applies a function into a container. And I know every time I say container, someone out there, an angel loses its wings, but that's how I think of it. Another way to think of a functor is the functorial operation map lifts a function over the container-like structure so that it can apply to the thing inside. So that's the functor part. The monoidal part is the function we call mappend, where you're taking two things and smooshing them together. So I think the reason I dislike applicative so much is that the combination of these two things at once, the lifting over and the smooshing, does not fit in my tiny simian brain. And to be clear, when I say I don't like applicative, that's entirely an aesthetic statement and is not meant to say that applicatives aren't useful. Surely they are, but they don't work well in my brain. So we are on the last exercise, which I spent about 15 minutes to half an hour working on off camera. And the end of our last episode, I basically gave up and said, I'm going to go away for a week. Well, I've been working on this for a week and I've reached several different implementations and I don't love any of them. And in particular, it's not that I don't like the implementations, it's that I don't like how I got there. So after I managed to kind of blunder my way to a solution, I went and looked at some other implementations of this. And it was fascinating to me because none of them looked anything like each other. So there's a lot of ways to implement this. I'm going to try and blunder once again to the solution that I got to the first time, which looks the most like the solution provided by Brian McKenna in his video series. I'm going to put a link up here, and I really do recommend his Data 61 series. It's just, he just makes it all seem so easy, even for things like this that for me at least are not. So what are we doing here with filtering? So for something that is an applicative, we have a function that takes some value A and yields a bool in a context, and it takes a list and it returns a list in a context. So this looks like a few different things, right? First of all, there's a function in list called filter. Oh, what happened to my list? Right? That looks similarly. I just broke everything. Can I undo here? That looks similar but different, right? We can't just use this filter function because the types in the context are different. The other thing it looks a little bit like shape-wise is this sequence, right? Where we've got a list of some things in a context and then we return a context of list. So what are we going to do with this? Well, we're going to try and use holes to tell us what to do. We're going to try and follow the types. So first we have two arguments here. We have a predicate, right? And we have a list. Once again, I'm going to follow my practice of using as detailed names as I can rather than names like X and Y, although at some point it may be unavoidable. So let's just start right like that. And we look at our hole, and what do we have? The hole is, as we expected, a context with a list in it. And we have a few bindings. We've got a list, we've got a predicate, and we have the whole signature. So one of our key inputs here is this list. So probably we're going to do some sort of fold. Let's do a fold right. What are our arguments for our fold? There's going to be a function, right? There's going to be some accumulator, and there's going to be the list itself. That's what I think they are. Let's reload that and make sure the types are what I think they are. Lots of holes. Okay, list is a list. That's good. Accumulator is our result. And that's our function. All right, so the easy one here is this list. And that's just going to be our argument. We knew that going in, but I'm being bloody minded and doing it step by step. So our accumulator is this list in a context, and we have something that lifts things into a context in applicative. We have this pure function. So it's going to be pure of the empty list because we're folding, right? So now we're down to, this is what frustrated me about trying to do my own solution for this. I got to this point, I'm like, this is easy. I just got to figure out what goes in the hole here for the function. And it turns out that that's more complicated than I wanted. All right, so we've got some A, we've got, right? That's the accumulator that's coming in, and that's our result. We don't have an A yet. We have a list of A's, and we have a predicate. So how do we get an A? Well, we need a function, right? And that's going to be here. Let's call it, right? And then we've got an accumulator. And then we have something here. And so now what I expect is the same, kind of same shaped hole, but with more items in our context, right? Our hole is still a K of list A. And we have a K of list A. Of course, it's just empty, but would that actually, I kind of want to try this. And what I expect is that this might actually compile, but would do the wrong thing. Okay, it does compile. That's great. Let's test it. It'd help if I spelled things right. Well, that was unusual. It got confused. All right, so as expected, our filtering tests pass. And we can see the way, fail. And we can see that the way it's failing is we expected exactly one something, but it got exactly one nil. We expected full something, but we got full nil. And this is exactly the sort of failure that we would think this code would do. We're passing in pure nil as the accumulator. We're returning the accumulator. We're not doing anything. So that's not good enough. We knew that. But I was happy to reach a point where it type checked. Okay, so what are we going to do here? Let's put our hole back, and it still needs to be an accumulator. It still needs to be a K of list A. And what do we have? Well, now, unlike the last time we did this without the function, now we actually have an A, right? That's our item. And we have a predicate that goes from the item to a K bool. Okay. I'm going to do something that probably makes this look uglier, but helps me keep it separately. I found that when I had all of this stuff on one line, it was really confusing me. Can I do this? No. Does not like that. Why doesn't it like that? can't use where in this context. Can I use let? Oh, wait a minute. No, because this, of course, won't work because I'm outside of the context. So I actually do need to do let test equal pred item in whole. Okay, so now I have this test, which is a k bool. And obviously, if we look at the implementation for filter, the list version, right, we could see we've got this code here. If this, then that, else that, which feels like what we want. But the problem here is that we don't have a bool to feed to if. We have a bool in a context. So some sort of lifting is going to be necessary here. So if some sort of lifting is required, let's put it in parentheses, whole, and we're lifting it. Is that right? Yes, because we're lifting that k bool in, right? Parse error. No, because this gets fed into it, I think. Lots there. All right. What have we got? So we found our whole. Our whole is going to be some sort of function that's going to take some ambiguous type variable and a bool, and it's going to return a list. So that feels like now we've got a list. So that's not in a context anymore. Okay, so that's good. Whole 2, something in a context. And we have a k bool, that's in a context. So I need to bind these things, right? So this ack here is not helping because we're not using it for anything. I've got some extra stuff here that I don't think I need. Right? All right, so this is better. So now, whatever this inner function is, it goes from a list to a list. It's taking a list. And we have our dunno is our bool, actually, which is what I wanted to see. So this can now be all right, which means this, now that we have a test result, these should both be just a list type, I think. Okay, they are. No, they are functions from a list. I think I see, I had that over there, but I think I want it here. I haven't yet passed it in, have I? Got a lot of bindings here. I think I need to pass it in all the way. I think I was right the first time. I don't know. So what I'm doing here, like, I want a shadow ack, if that makes any sense. This needs to be Does that work? All right, this is a case where giving this a name is actually confusing me. Because it's adding a binding that I don't need. Okay, hole 2 is A, hole 1 is A. That feels wrong. I expect that A to be a list A. There. Okay, so see, so much of this is implicit based on positioning. I'm a bear of little brain. One of the best features I always felt of Objective-C was the idea of having types with names in them. But that's not how this works. Okay, but now we've got list A. So that's progress. We have our 2 holes left, H1 and H2. Well, H2 is if this test fails, so that's just going to be that, if I have that binding available, and I do. And so this logically has to be the item prepended to that list. Let's see if that gets us there. Well, we've had things type check before and not had them work, so let's try it. All right, so that's what this looks like in my follow the types version. And again, I feel like I just had a really rough time getting here. The use of lift, something about, I think I said this before, but I'm going to repeat myself, something about combining the lifting operation and the monoidal smoosh just confuses the heck out of me. As I said, I've gone and looked at various implementations of this. The official solution for this, I look at it and I can barely make sense of what's happening. I've seen versions where people aren't using fold, but are simply explicitly recursing. This has a lot of bindings, a lot of names. There's probably ways to clean this up to make it more readable. This makes me worried because our next chapter is going to be monad. And if I'm having trouble with this, where's monad going to leave me? Maybe this is where my dilettante level makes me stop teaching this course. I shouldn't even say teaching at this point because I feel like I'm the blind man feeling the elephant, and you as the viewer are probably doing better at this than I am. But maybe this is what makes me stop talking about this course. Nonetheless, I'm going to try and keep going because I know enough about monads that I feel like applicative, as I said when we started applicative, I feel like applicatives are actually harder and more complicated of a concept. We'll see if that's true when we continue this in 1 or 2 weeks. Thank you for joining me on this very embarrassing journey. You have been watching Tea Leaves Programming. We're programming like it's 1979 and doing Haskell for Dilettantes. Thanks for watching.